This video lecture follows right along with your Chapter 5, Section 3 lecture notes. In this lesson, we'll be learning how to add and subtract polynomials. A polynomial in a single variable x is a sum of terms of the form a times x raised to the exponent of n, where a is a real number and n is a whole number. A monomial is a special type of polynomial with only one term. A binomial is a polynomial with two terms. And a trinomial is a polynomial with three terms. After 3, we don't have special names for those polynomials. Each term in a polynomial has its own degree, and the degree of each term in a polynomial that only has one variable is equal to that variable's exponent. Let's look at the following examples. We're going to classify these as monomial, binomial, or trinomial and list the degree of each term. In part A, this polynomial has 3 terms, so this is a trinomial. The second one has 2 terms, so it is a binomial. And the last one only has 1 term, so it's a monomial. Now let's look at the terms one at a time, listing their degrees. First, we'll start with the term x squared. Since the exponent of the variable is 2, this term has degree 2. Looking at the term negative 9x, the variable x has an exponent of 1, so the degree of this term is 1. The term 20 doesn't have the variable written with it. If we wanted to write the variable, we would write it as x raised to the exponent of 0. Therefore, the degree of this term is 0. We again have the term x squared, and since the exponent of the variable is 2, this term has degree 2. Looking at the term negative 81, this does not have a variable written with it, but we can write this as negative 81 times x to the 0, which is 1. So the degree of this term is necessarily 0. Finally, looking at the term negative 92x to the 7th, the variable x has an exponent of 7, so the degree of this term is 7. The coefficient is the numerical part of a term, or the number that's usually out in front of the variables. Let's take a look at this example. We are asked to determine the coefficient of each term of this polynomial. Let's list out each term and then determine its coefficient. This polynomial has 4 terms, x cubed, negative x squared, negative x, and positive 20. It's really important that the sign in front of the term stays with the term. The term x cubed does not have a number written out in front, but we know that this is really 1 times x cubed. So the coefficient of this term is 1. Looking at negative x squared, the numerical part of this term is the negative 8. So the coefficient is negative 8. Next, we have the term negative x. You can think of this as negative 1 times x, so the coefficient of this term is negative 1. And finally, the constant term 20, the coefficient is just 20. That term only has a numerical part, and that numerical part is the coefficient. Now that we understand how to find the degree of each term of a polynomial, we need to talk about the degree of the polynomial. The degree of the polynomial is the degree of the leading term. That's the first term of the polynomial. Now, if we write the terms of the polynomial in any order that we want, then we could have different leading terms or different degrees for that same polynomial. It's going to be vitally important that we always write our polynomials in descending order. That means we want to write the term with the highest degree first and descend down to have the term with the lowest degree last. Let's take a look at this example. We're going to rewrite the polynomial in descending order, identify the leading term, the leading coefficient, and finally the degree of the polynomial. Notice that the term with the highest degree is this term, negative x cubed. So we want to write that term first. The term with the next highest degree is a positive 4x squared. So we'll write that second. The term with the next highest degree is x to the first. So we'll write plus x for our third term. And finally, our constant term plus 9. Now that we've written the polynomial in descending order, we can identify that negative x cubed is the leading term. This leading term has a coefficient of -1, so we say that the leading coefficient is -1. And the degree of the leading term is 3, so the degree of the polynomial is 3. We say that this is a degree 3 polynomial. To evaluate a polynomial simply means to substitute a value for the variable in the polynomial. For example, we want to evaluate x cubed plus 7x squared minus 6x plus 40 for x equal to -3. That means that we want to place a -3 in each location of the polynomial where there's an x. Making this substitution, we have -3 cubed plus 7 times -3 squared minus 6 times -3 plus 40. Simplifying, we first have -3 cubed. That's -3 times -3 times -3, or -27. Next, we have 7 times -3 squared, or 7 times 9. Next, we have a -6 times -3, or +18. And finally, a plus 40. 7 times 9 is 63, so we can again rewrite this as -27 plus 63 plus 18 plus 40. Notice the good order of operations that we used here. We first simplified our exponents that we had, we then did all of our multiplication, and finally we will add and subtract. Combining all of these terms together, we get a sum total of +94. We've now evaluated this polynomial for x equal to -3. Now let's switch this conversation over to polynomial functions. A polynomial function is simply a function that's described by a polynomial. In previous lessons, we've discussed linear functions, and those are functions of the form f of x equals mx plus b. This is an example of a polynomial function. We have an x raised to the first power, so it's a degree 1 polynomial or a first degree polynomial function. Another example might be something like this. F of x is equal to x cubed plus 12x squared minus 21x. Notice that we have a function f of x, and it's described by a polynomial, in this case a third degree trinomial. Let's take a look at example 5. Here we have the function f of x equal to x squared minus 8x minus 35. We need to find f of 10. To find f of 10, we need to substitute a 10 everywhere in the function where there's an x. So this gives us 10 squared minus 8 times 10 minus 35. Simplifying, we have 10 squared, or 100, minus 8 times 10, which is minus 80, minus 35. And combining these, we get a total of -15. So f of 10 is -15. Now let's begin adding polynomials. To add polynomials, we simply need to combine their like terms. For example, let's add x cubed minus x squared minus 9x plus 25 to x squared plus 12x plus 144. If we look at the first term in our first polynomial, we have an x cubed. Since there's no x cubed in the other polynomial, we do not have a like term to combine with this one, so we'll simply write x cubed. Next, we have a -x squared. In the other polynomial, we have a +x squared. Let's write those two terms next to each other. Notice that those two like terms will add to 0. Next, we have a -9x. In the other polynomial, we have a like term of +12x. Finally, we have a constant term of 25 in the first polynomial and a constant term of +144 in the second polynomial. This intermediate step of writing the like terms next to each other can help you simplify. First, we just have x cubed. Then we have -x squared and +x squared, which add to 0. Next, we have -9x plus 12x, which combine for a total of +3x. Finally, we have +25 plus 144, which add together for a total of +169. Now we've added these two polynomials by combining their like terms. Let's now talk about subtracting polynomials. When subtracting polynomials, we're going to change the sign of each term that's being subtracted and then combine like terms. Notice that this is the exact same thing as using our distributive property with a -1 on the outside of the parentheses. We will then combine like terms just like when we were adding polynomials. Let's first rewrite this difference with the negative distributed to the second polynomial. So we have 3x squared plus 6x plus 6 minus 4x squared plus 9x minus 15. Combining like terms, we have a positive 3x squared and a negative 4x squared. Combining those like terms, we get negative 1x squared, or simply negative x squared. We also have a positive 6x and a positive 9x. And combining those like terms, we have a total of positive 15x. And finally, we have a positive 6 and a negative 15, which combine for a total of negative 9. Now we've successfully subtracted polynomials. Changing the language just a little, let's subtract polynomial functions. We have f of x and g of x, and we're going to find f of x minus g of x. Substituting the polynomials for their respective functions, we could rewrite this as 4x squared plus 30x minus 45 minus negative 2x squared plus 17x plus 52. Hopefully you can see that parentheses will be very important in this case to make sure that we distribute the minus sign to each term of the polynomial being subtracted. Let's start by distributing. This becomes 4x squared plus 30x minus 45 plus 2x squared minus 17x minus 52. This also allows us to drop the parentheses. Combining like terms, we have a 4x squared and a positive 2x squared. Combining these like terms, we have 6x squared. Next, we have a positive 30x and a negative 17x. Combining those like terms, we have a positive 13x. And last, we have a negative 45 and a negative 52, which combined give us a total of negative 97. So f of x minus g of x, the difference of two polynomial functions, is another polynomial function. Let's now evaluate this polynomial for the given values x and y. Notice that this polynomial has more than one variable. Our polynomial expressions up to this point have only had one variable. We need to place a -2 in each location where we find an x in the polynomial, and a positive 5 in each location where we find a y. Making these substitutions, we have -2 squared minus 9 times -2 times positive 5 minus 4 times 5 squared. Simplifying, we have -2 squared, which is positive 4, minus 9 times -2 times 5, or positive 90. Finally, we have -4 times 5 squared, or -4 times 25. That's -100. Combining these together, we have a sum total of -6. And now we've evaluated a polynomial in two variables. When we have a polynomial with more than one variable, we need to calculate the degree of each term differently. The degree of a term is equal to the sum of the exponents of all of its variable factors. Let's take a look at this example. We're going to find the degree of each term and the degree of the polynomial. First, let's look at the term x to the 5th. This term only has one variable, and the exponent of that variable is 5. So the degree of this term is simply 5. Our next term is -3 times x squared times y to the 6th. This term has two variables, so the degree of this term is the sum of the two exponents. That means that the degree is 2 plus 6, or 8. Our third term is positive 8x to the 9th times y. Notice that this is y raised to the exponent of 1. The degree of this term is the sum of the exponents of the variable factors. So the degree is 9 plus 1. If we were to write this polynomial in descending order, with the term of highest degree first and the term of lowest degree last, we would write this as 8x to the ninth y minus 3x squared y squared plus x to the fifth. That means our leading coefficient is 8x to the ninth y, which has degree 10. That also means that the degree of this polynomial is 10. Let's go on to our final example. In this last example, we're going to add these two polynomials with multiple variables. We need to identify like terms. Notice our first term. We have 5 times x to the fourth y squared. Any like terms will also have x to the fourth and y squared, like 8x to the fourth y squared in the other polynomial. We also have negative 6 times x cubed y cubed. Any like terms would need to have x cubed and y cubed, which we have with this term of 2 times x cubed y cubed. Combining our like terms, we have 5x to the fourth y squared plus 8x to the fourth y squared for a total of 13x to the fourth y squared. We also have a total of negative 4x cubed y cubed. And we've now added these two polynomials with multiple variables. And that will conclude this lecture video on the addition and subtraction of polynomials.